Hello everyone, I'm going to go over the solutions for project 1, which is also a review for test 1. All right, so you are expected to download this project posted on Canvas and use it to prepare for test 1. If you can do all these problems on your own comfortably, then you should do very well on the test, because the tests are going to be very similar to these type of questions, except maybe one or two multiple choice extra problems will be there on test 1, but otherwise for the majority of the problems the test will be very similar to the ones in this project. All right, so please download this and use this to prepare for the test. So I'm going to go over and explain the solutions for some of these problems. So as you're working, you can check your answers against mine, but again, make sure that you have worked on this yourselves, because that's the only way you will be able to prepare. All right, just watching these solutions will not give you the practice you need to do well on the test. Now, the first question says a hypothesis test is to be performed to determine whether the mean waiting time during peak hours for customers in a grocery store has increased from the previous mean waiting time of 8.3 minutes. Preliminary data analysis indicate that it is reasonable to apply a z-test, and then they've stated the hypothesis. So what they are looking at here are the mean waiting time during the peak hours for customers in a grocery store, perhaps at the checkout counter. And what they want to test is if that time, the average wait time, has increased from a previous wait time of 8.3 minutes. Have the lines become longer and the customers have to wait longer in line than it was previously. So the previous wait time was 8.3 minutes, and what it says here is whether it has increased. So that's going to give you the clue for the alternate hypothesis, right? So when they state the hypothesis, they've already stated it for us. Null hypothesis colon mu equals 8.3 minutes, and alternate hypothesis is mu greater than 8.3 minutes. And that greater comes from this wording in the question which says increased, right? So this greater, the alternate hypothesis, the greater sign tells us it's going to be a right-tailed test. Now, here we are actually not performing a hypothesis test. You're going to be asked to find the probability of making a type 2 error. That means you have to find the value of beta. So the other information they've given us is the population standard deviation is 3.6 minutes. The sample size is 45. The significance level is 0.05. That's alpha. Find the probability of a type 2 error, which in other words is going to be our beta value. If in fact the mean waiting time mu is 9.8 minutes. Again, keep in mind, type 2 error occurs when the null hypothesis is assumed false, right? We commit a type 2 error when the null hypothesis is in fact false. So null hypothesis is not 8.3 minutes, but if it is 9.8 minutes, what is the probability of making a type 2 error? That's what they are asking for in the question. So first we list our data. We extract all the data from the question. Standard deviation sigma is 3.6 minutes. I noted down here n, which is the sample size is 45. I noted down here alpha is 0.05, which is the significance level alpha. And mu sub 0, which is the null hypothesis mean, is 8.3, and the alternate hypothesis mean is 9.8, all right? The mean that is assumed to be true instead of the null hypothesis mean. All right, so the first step is to find the cutoff value for z of alpha, which is z of 0.05. And in the first step, what we do is we find the critical value based on the fact that the null hypothesis mean is true. The critical value we used in order to perform the hypothesis test with mu equals 8.3. All right, so you can look up your tables. It should be a value 1.645. Let me use a different color. 1.645. I've drawn a diagram. You should also do the same. Show where your z of 0.05 is. It's a right-tailed test, correct? It's a right-tailed test, so your reject region in the original hypothesis test would be on the right-hand side. Do not reject on the left. And the cutoff, the critical value would have been 1.645. Was 1.645, given that the null hypothesis was located at the center point with a value of 8.3 minutes. All right, so that's the first step. You find your z of alpha. In the next step, you have to find the x bar value, the sample mean value corresponding to z of alpha, using one of the formulas. There were 3 formulas given to us. We have to use the one which applies for a right-tailed test. So we are finding the corresponding x bar value for a z value of 1.645. And we use this formula mu plus z of alpha times sigma over square root over n. And when we plug in all the values, we get a x bar value of 9.182. Let me remove this. A value of 9.182. All right, that's step 2. So first you find your z alpha value in step 1, draw a diagram. In second step, you find the x bar value, the sample mean value corresponding to the critical value. In step 3, we find the z value by plugging in the alternate mean. All right, so what we do here is find the z value when x bar is 9.182 and mu of alpha equals 9.8, which is the alternate mean. So the formula again to find the z value is x bar minus mu. Here we are finding the z value from the x bar value we found in step 2 and the alternate hypothesis mean. All right, so 9.182 from step 2, 9.8, which is the alternate mean, which is assumed to be true instead of the null hypothesis mean, divided by 3.6 is the value of sigma that was given to us, divided by square root over n being 45, and we get a z value of negative 1.15. Hope you can see that, otherwise I'll remove the highlight and just underline with red. All right, so z value is negative 1.15 when we replace the center point with 9.8 with the alternate hypothesis mean. All right, and then we see where the x bar value that we found from step 2 now lies, all right, in our new diagram after replacing the center point with 9.8, with a mean waiting time of 9.8. And we see that the z value is negative 1.15. That means this cutoff has now shifted towards the left. All right, it has shifted towards the left, further out. All right, so that where our reject region has essentially expanded. All right, it used to be here when we use the null hypothesis mean at the center. When we replace the null hypothesis mean with 9.8 with an alternate mean, then the whole diagram gets rescaled. All right, what was the critical value before now becomes negative 1.15, all right, based on this calculation here. All right, so now that we have our new z value of negative 1.15, we have to find the area of the do not reject region, because remember we are finding beta. And what is beta? Beta is the do not reject region. All right, that's what beta is. So for beta sub 1, we find the area of do not reject region, that is area to the left of z of negative 1.15. All right, so that means this. This area is what we are interested in finding. Okay. Because beta is the do not reject region. That's what beta is. So if it's area to the left you have to find, it's very easy to find from the table. Just go to the table with a value of z value of negative 1.15 and you'll get the value of beta, which is 0.125. That's beta. If they ask you to find the power of the test, you have to just do 1 minus beta. So let me just, just a second. Let me write it here. Here, the power is 1 minus beta. So just subtract whatever you found for beta from 1, and that should give you the power. All right, so this is the solution for the first question in the project. Now the second question is a hypothesis test question. It says it's on apparel and services. According to the document consumer expenditures, the average consumer unit spent $1,736 on apparel and services in 2012. That same year, 25 consumer units in the Northeast have the following annual expenditures in dollars on apparel and services. And they've given us the data here. They've given us the data here for the 25 consumer units in the Northeast, right? The question is, at the 5% significance level, do the data provide sufficient evidence to conclude that the 2012 mean annual expenditure on apparel and services for consumer units in the Northeast differed from the national mean of 1,736? So the national established mean was this figure here, 1736. And a sample study was done in a more recent year and on 25 consumer units, and this was the data obtained from those 25 consumer units. The question is, we have to perform a hypothesis test to show whether the data provides sufficient evidence to conclude that the mean annual expenditure on apparel and services differed from the national mean. All right, so this is a key word here which we are going to use to state our alternate hypothesis. And it says here you need to find the sample mean and the sample standard deviation first. So they haven't given us what the sample mean is. They've just given us the individual data points from those 25 samples, 25 units. They haven't given us what X bar is. We need to find that. And they haven't told us what the population standard deviation is. So we have to find what's called the sample standard deviation. All right. So the first step is to calculate the mean X bar if it is not given to you. Now on the test, in the interest of time, we will probably give you the sample mean. All right, this is just an exercise to give you some practice on how to calculate the mean. All right, so just sum up all these values, divide by 25. So sigma x divided by n is the formula for X bar. Sum up all these values and this should be a comma. All right, 48,069 divided by 25, and we come up with a sample mean value of 1922.76. All right. The next step is to calculate the sample standard deviation, because, and I'm going to write here sample standard deviation, because the population standard deviation is not known. They've given us what the population mean was in 2012. It was 1,736, but they haven't told us what the standard deviation, population standard deviation was. So we have to find the sample standard deviation from our sample, and that value is 350.90. All right, 350.90. N is 25, the sample size. We do need that in our formula. And then the mean, the null hypothesis mean is going to be the established mean of 1,736. Alpha is 0.05. Where do we get that? From the significance level, here. And this is a two-tailed test, as we will see. That's the reason I have alpha by 2. All right, so let's state the hypothesis. That's the first step of any hypothesis test. Null hypothesis mu equals 1736. Again, I want to remind you that the null hypothesis must always have an equal sign in it, and it should always be stated in terms of the population notation. It's going to be the population mean equals 1736. I should not have an X bar, all right? We always state the hypothesis in terms of the population. Alternate hypothesis will state that the mean is not equal to 1736. How do I know it's not equal to? Why not less or greater than? Because in the question it says differed from the national mean. All right, if it says different, or if it says it's not equal, you have to use the not equal sign in your alternate hypothesis. So that's going to make it a two-tailed test. So now that we've stated our hypothesis and we also determined our alpha is going to be 0.05, we are going to find the test statistic. That means the evidence from our sample data. So the test statistic is going to be calculated for using this formula. Now it's going to be a t-test because we are not given the population standard deviation. We are working with our sample standard deviation, so it's going to be the t-distribution that we have to use. So we plug in all our values into the formula. Again, you will be provided a formula sheet on the test, and as well as tables and everything that you will need. All right, so x bar minus mu divided by s divided by square root over n. When we plug in all these values, we come up with a t sub 0 value of 2.661. All right, 2.661. Okay, so now that we got our test statistic value, we have to go on to using the different approaches to come to a decision. The first one is the critical value approach. Now it's a two-tailed test, so the reject regions are going to be on both ends of the curve. You do have to draw a picture with your work, all right, when you're using the critical value approach. Your curve, again, this is a T curve. Draw the reject on both sides. If it's a two-tailed test, in the center is going to be the do not reject region. Now we have to find the critical value of what? Of T of 0.025. So here, for a two-tailed test, we have to divide our alpha into 2. Oops, sorry about that. Let's go back. Here we are. All right, so we divided our alpha over here by 2 in order to split it over the two reject regions. All right, so what we are finding is plus minus t of 0.025, and there is a df involved in t distribution. And what is the formula for df? Df goes by the formula n minus 1. So n is 25 minus 1 is 24. That's how I got the 24 for the df. And if you look up your table, you're going to get a t-value of plus minus 2.064. It's very important that for a two-tailed test, you write the critical value as plus minus 2.064. So now that we have found our critical value, bring your test statistic value 2.661. We have the diagram up here. Show in the diagram where the 2.661 falls, where the test statistic falls. It falls in the reject region, correct? 2.661 is greater than 2.064, which is the critical value. And if it is greater, that means it falls to the right of this, the positive critical value on the right hand side, which is the reject region. So it falls in the reject region, therefore we reject our null hypothesis. All right. Now for the p-value approach, we bring our test statistic. We always start with the test statistic in the p-value approach. There's no do not reject regions in the p-value approach. All we do is bring our test statistic with DF of 24, and we look up our table to find the area to the right of 2.661. All right. So draw your diagram, all right, on the test. Please draw your diagram. Show where 2.661 would fall on that diagram. And what you can do is find the area on the right-hand side, wherever 2.661 is. And then you have to multiply that by 2, all right? You have to multiply the p-value by 2 just because it's a two-tailed test. And then you compare it with alpha, which is 0.05. All right. Now, if you want, another way of doing it is you can keep it as 0.0038. You need not multiply it by 2. But in that case, make sure you are comparing it with 0.025. All right. Which is half the significance level of one side. All right, so we compare 0.0038 with 0.025, or 2 times 0.0038 by with alpha, which is 0.05. It's less than alpha, therefore reject null hypothesis. Okay, so the decision is to reject null hypothesis. It's very important in the last step, which is to interpret it. And the way you interpret it is at the 5% significance level, there is sufficient evidence. If it's a reject decision, you have to state that the data do not provide, the data is strong enough, right? So if it is a reject, like in this case, if it's a reject decision, then the data was strong enough to reject the null hypothesis. So you're going to say there is sufficient evidence to conclude that the 2012 mean annual expenditure on apparel and services for consumer units in the Northeast differed from the national mean of 1736. Because it's an application-based problem, it's very important for you to state it in context of the problem, all right? Please do not just say that to conclude that the null hypothesis can be rejected. All right, that's not enough. You lose points. If it is a word problem, to write a complete interpretation, you do need to state it in context of the application problem. All right. So these are the keywords you need to include in your interpretation. You should say at the 5% significance level. You should qualify it at with the criterion you used. And then you have to say, this is also important, whether you said correctly provide sufficient evidence or does not provide sufficient evidence if it is do not reject case. And then, of course, you have to state it in context of the problem. All right, the last part. So the interpretation itself will carry at least 3 points, could be more. All right, so make sure you complete all the steps completely in a hypothesis test.